Next, let's talk about primality tests. And the idea with this is, so a primality test is a test basically to determine whether a number is prime or composite. And the idea is that primes are just useful to know about for theoretical purposes, but also for applications like computer science and cryptography, which we will talk a little bit about later this week. So people are quite interested in figuring out whether numbers are prime or not, and here are a couple ways of doing that. So the most naive thing you can do is trial division, which just means try all the possible factors. So let's do an example of this to illustrate it. So, is 101 prime? I wrote it down in one of those prime factorizations above, so it, had better be, but I haven't proven that, so let's check it. Well, it is not divisible by 2. Just from looking at it, you can see that it is odd. It is also not divisible by 3. So I hope you remember your divisibility tests, but if you have forgotten, you can tell if a number is divisible by 3 by adding up the digits and seeing if that is divisible by 3. So if you add up the digits of 101, it adds up to 2, and that is not divisible by 3. Nor divisible by 5, because again, you can just look at the last digit and it has to be a 0 or a 5. It is not. For 7, I don't know. I think there is probably some test you can do for 7, but I don't remember what it is. I think it's kind of lame. So let's just say, okay, 77 is a multiple of 7, and then 84, 91, 98, and then 105. These are the multiples of 7. So we missed 101, so it's not a multiple of 7. And then so on and so forth. You can continue checking. But you can actually stop here. Because let's have this little fact. If n is composite, then it must have a factor that is at most square root of n. And let me give a little proof sketch. So not a full precise proof, but a little suggestion of why this is true. If n is a times b, then a must be less than or equal to root n, or b must be less than or equal to root n. Because otherwise, when you multiply them, AB will be larger than n. But we said they are equal, so this is impossible. So it suffices to check up to square root of n. And in our case, square root of 101, square root of 100 is 10, so this is about 10. And these are all the primes less than 10. So we conclude 101 is prime.